Hey guys, so this is our week 8 wrap-up video. So this was our first week where we started looking at organic chemistry. And so there's a little bit of a shift here. So most of our class so far has focused on general chemistry, which contained a lot of math. And now we're kind of gearing up for organic chemistry. And you'll still need a lot of the foundational principles that we learned in general chemistry to understand everything in organic chemistry. But it's also kind of like learning a new language um, rather than so much math. All right. So going through the comments in Top Hat, this was one of the questions. Identify the functional group in the following molecule as an alkane, alkyne, an alcohol, or a carboxyl. Remember, it's this suffix, the ending of the word, that kind of gives you a clue to what the functional group is. So ANE is all single bonds, YNE is triple bond, alcohol is an OH group only, and the carboxyl is this COOH, this COO. So, and that, if you were to write it out, would be a carbon with a double bond to one of these oxygens and a single bond to the other oxygen, and then that oxygen is binding the other hydrogen. There is a double bond here, and we learned in this lesson that that is called an alkene, but notice that was not an option. That's alkene with a ENE ending, and that wasn't an option for this question. So the answer for this should have been carboxyl. And there will be several times when an organic molecule has more than one functional group, but we'll keep it pretty simple for this class. All right, another question you guys had was classify the following compound as organic or inorganic. It was written like this because at the time, I don't know why it was written like this, but again, hopefully you guys figured out that this meant that there's 30 carbons, 48 hydrogens, 3 oxygens, and 1 nitrogen. So again, this would be another way to represent that. If you look at the atoms in this molecule, they're all carbons, hydrogens, and oxygens, and nitrogen. So we would say that this is an organic molecule. Inorganic will usually contain a metal. So left side of the periodic table, that's how you can figure out if something's organic or inorganic. All right. Someone asked the question, do all hydrocarbons undergo combustion? Yes, they do. So this is just an example. Hydrocarbons, something just made of hydrogen and carbon. And sometimes there can be oxygen in these molecules as well that undergo combustion. But combustion is when you just have this hydrocarbon reacting with oxygen. There has to be a source of ignition, okay? And you always get, if the reaction was perfect, you get water and carbon dioxide. And then, of course, heat or energy is released in the reaction. Sometimes that is shown in the chemical equation, sometimes it's not. So another question you guys asked was, when determining the amount of isomers, the normal alkane is included? Yes, that's the short answer. So what do I mean by that? So if you have this molecule pentane, it has 1, 2, 3, 4, 5 carbons, and it has 5, 10, 11, 12 hydrogen. So this is C5H12. This is also C5H12, 1, 2, 3, 4, 5, and then 3, 6, 7, 8, 9, 10, 11, 12. And this is also C5H12. But notice they're put together differently. So these are what we call isomers, okay? They're just stuck together differently. So if we want to know how many isomers have the chemical formula C5H12, we would say 1, 2, 3. Okay? So yeah, I'm assuming what you mean by normal alkane is pentane, so the straight chain alkane. Yeah, we would include that as one of the isomers. Oh, I messed up on this module, and thank you guys. Several of you pointed out this mistake, so I just wanted to clarify it in this wrap-up video. The condensed structural formula for butane, well, this is just one of the comments I pulled. You guys thought it would be CH3, CH2, CH2, CH3. Yes, that's absolutely right. So on the top is what was there. On the bottom, I went ahead and fixed it so that it shows the correct condensed formula, and I apologize for that, and I really appreciate you guys pointing it out. I'm sure your classmates do too. Okay. All right, so another question was, if 25 mils of hexane were added to 100 mils of water in a beaker, which of the following would you expect to happen? Okay, so a couple things before we even look at the answers. You need to know that hexane, that ANE ending, right, tells you you have an alkane. The hex tells you there's 6 carbons in there, okay? But the ANE here is telling you 6 carbons. So we have carbons and hydrogens. So we know that they're non-polar bonds. That means it's a non-polar molecule, okay? And now see, this is something we've already covered in our general chemistry portion of this class. So you should know that hexane, from here you should know that hexane is non-polar. From before, you should know that water is polar. And from before, you should know that non-polar substances do not dissolve in a polar substance. Remember, like dissolves like. So non-polar substances dissolve in other non-polar things, and polar substances dissolve in other polar substances. So let's go through our options here. Hexane would dissolve in water. No, it wouldn't, because hexane is nonpolar and water is polar. So nope. Hexane would not dissolve in water. That is true. And would float on top. Okay, so now we're thinking about the density. So let's come back to that. Let's look at this one. Hexane would not dissolve in water and would sink to the bottom of the container. So if you go back and you look at the information in Top Hat, you'll see that most of the alkanes have a density lower than water, so they tend to float on top until you get to the really big ones. But so hexane would not dissolve in water because, again, they have different polarities, and it would float on top of it. So the middle bullet would be the right choice for this question. Okay, so you guys had some questions about IUPAC nomenclature. Sorry, I forgot to erase this slide. But so let's kind of, just quickly review some of this IUPAC nomenclature. First thing, you need to know kind of like a 1 carbon group will always have the prefix meth. 2 carbon groups always have this prefix of eth. 3 carbon group has this prefix of pro. 4 carbon group has this prefix of bute. 5 carbon group has a prefix of pent. 6 carbon group has a prefix of hex. 7 carbon group has a prefix of het. 8 carbon group has a prefix of oct. And that's going to be really important because as we go through this organic chemistry section of our course, those prefixes are going to come up over and over and over again. Okay, so this is something you can make flashcards for, you can do a Quizlet for, you can put it up in your bathroom or somewhere where you read a lot, maybe on your fridge, I don't know, on your door, put it somewhere you look a lot. You need to learn these prefixes. And of course, these all have A and E suffixes at the end because they're all carbon hydrogen single bonds. Okay, so that's kind of the first part for this naming. So there's kind of, some rules you can follow, and they were also given in your Top Hat content. So if you're gonna name an organic molecule, here's kind of 3 kind of straightforward. Now, I will be honest, naming can get pretty complicated, but for this course, we keep it pretty straightforward, okay? So the first thing you wanna do is you wanna find the longest continuous chain of carbons, okay? So that parent name is gonna indicate how many carbons are in that longest continuous chain, okay? The suffix at the end is going to tell you what kind of functional group is present. Now, again, we're going to get to the cases where there's more than 1 functional group present, and then there's some priority that takes place, okay? And then the prefix out here in front is going to tell us what kind of substituents we have, where they are, and how many there are attached to our longest continuous carbon chain. Okay, so there's kind of 3 parts. Again, the suffix tells us the functional group. The kind of parent, the root of the word, tells us what's the longest carbon chain. And the prefix tells us where and how many and what are the substituents on this chain. Okay, so a lot of you guys had questions about halogenated alkanes as well. So we can kind of start using those rules. There's a couple additional rules when you have this halogenated alkane. So we can see this bromine here. That's in the second to the last column on the periodic table. And so again, so some additional rules here is we're going to use the name of the parent alkane, okay, but we're going to put a prefix that's indicating which halogen is a substituent on this alkane, okay? And then in front of that, we're going to put a number telling us where it is, okay? So remember, first step is figuring out what's our longest continuous carbon chain, okay? So we got to count 1, 2, 3, 4, 5, 6. And I like to count, again, sometimes it's not in a straight line across, sometimes it might be bent. So you got to make sure you're checking all possibilities. So just for thoroughness, let's check here. 1, 2, 3, 4, 5, 6. So it doesn't matter if I start numbering 1 here or here, right? I still get 6. So number 6 goes with hex. They're all carbon hydrogen single bonds. So ane. So hexane is going to be like my parent name, and my suffix is going to be ane. Now I got to say where my substituents are. I always want to give my substituents the lowest number possible. So I can always number from left to right, or right to left, or up, down, right, left, however my chain might be going, okay? So if I go from left to right here, I end up with 1, 2, 3, 4, 5, 6. That puts my substituents at carbon 2 and carbon 4, okay? If I went right to left, it would be 1, 2, 3, 4, 5, 6. That would put my substituents on carbon 3 and carbon 5. I always want to give my substituents the lowest number possible. So in this case, I want a number from left to right. So that puts a methyl group. Again, it's a 1 carbon. Remember from that table, 1 carbon group is meth, right? Methyl. If it's a substituent, we add a YL at the end. Those are those alkyl groups. You had a top hat page on that. So this is called a methyl group, and it's at carbon 2. And then for our halogen groups, we use prefixes fluoro for fluorine, chloro for chlorine, bromo for bromine, and iodo for iodine, okay? So in this case, we have bromine, so we're going to use that bromo, and it's on carbon 1, 2, 3, 4, okay? And then we put them in alphabetical order, okay? Bromo starts with a B. It comes before methyl that starts with an M. It's on carbon 4, so we say 4 bromo, 2 methyl hexane, okay? And you should be able to look at this name and draw this compound as well. You guys should really practice that. Okay, you guys had questions about the cycloalkane, so I thought we could look at these examples. And there's lots of interesting rules displayed in these examples. So for instance, our longest continuous chain is these 3 carbons, but they happen to be in a ring. So we got to put the word cyclo in front. It's 3 carbons, so it's prop. They're all single bonds, so our ending is ane, okay? So kind of our root name is cyclopropane. But notice we have this substituent on it. Again, it's a 1 carbon substituent, so that's a methyl group. So the methyl just goes in front. We don't need any number because, again, we're always going to assume it's going to be the lowest number. So if we put that here, here, or here, it's the same molecule, okay? So this becomes methyl cyclopropane. All right, let's look at this one. So again, our longest chain is these 5 in a ring. So 5 has the prefix of pent. They're all single bonds, so it has an ane ending. Since they're in a circle, we're going to put the word cyclo out in front. So cyclopentane becomes our root parent name. We have these 2 substituents out in front. Notice they're both made from 1 carbon, so that's a methyl. That's our alkyl group. It's called a methyl group. We always want to give them the lowest numbers. So since they're next to each other, it's just going to be 1 and 2. We don't really have to figure out which one is 1 and which one is 2. It doesn't matter. But again, 1 and 2. And since there's 2 of the same substituent, we use this prefix of di, okay, meaning 2. Tri would be 3, okay? So that's telling you that it's 1,2-dimethyl cyclopentane, okay? So on carbons 1 and 2, I have a methyl group on each, and I have 5 carbons, all single bonds in a ring. All right. What if we have 2 of the same substituent on the same carbon? So our longest carbon chain here is 6 carbons. Again, they're in a ring, okay? So we have the prefix of hex, all single bonds, so a suffix of ane, ane. Since they're in a ring, the word cyclo goes out in front. And again, we're going to give our substituents the lowest number possible. So in this case, they're both on 1. So we got to say 1, 1 tells us that both substituents are on 1. we have that di prefix 2 telling us there's 2 of those methyl groups, okay? So the name for this ends up being 1,1-dimethyl cyclohexane. All right. Oop. Okay. So this one, we have a substituent directly opposite of another substituent. Notice on the right side is a 1-carbon substituent group, and on the left is a 2-carbon substituent group. And so remember, 1 carbon, we've had plenty, so that's a methyl group. 2 carbon is ethyl, like from ethane, but we're going to replace it with a YL because it's a substituent, okay? And so we can see that we have 6 carbons in a ring here. That's our longest chain. And so that's a hex, all single bonds, ANE ending. They're in a ring, cyclo out in front. So that's where the cyclohexane comes from. And then we have a substituent of a methyl group here and a substituent of an ethyl group here. Okay, so we want to number this to give our substituent that comes first alphabetically the lower number. So this is going to be carbon 1, and then 2, 3, 4. So our ethyl group is attached at carbon 1. Our methyl group is attached at carbon 4. So the name for this one ends up being 1-ethyl 4-methyl cyclohexane. Okay. So for this one, we have, again, a 6-membered ring, all single bonds. So our root name is cyclohexane. Here, again, we have an ethyl group, but this time we have 2 methyl groups substituted here. And so they are going to get a higher priority than this 1 substituent since it has 2 substituents. Again, we want our numbers to be the lowest in the naming. So we want it to be 1, these to be 1s instead of both being 4s. Okay, but we still got to list it alphabetically. So this becomes 4-ethyl 1,1, and then we got to use that prefix of dimethyl cyclohexane. Notice in all of these that dashes are used to separate numbers from letters, and commas are used to separate numbers from other numbers. Okay. Also notice that that prefix of the di in front of the methyl does not make it come before the ethyl alphabetically. Methyl is still going to come after ethyl. Okay. All right, here we have 7 carbons in a ring. So our parent name becomes cycloheptane. We have 2 substituents at carbon 1. One is a methyl group, the other is an ethyl group. We list them alphabetically. This is 1-ethyl 1-methyl cycloheptane. And here we have a 6-membered ring and a 3-membered ring. Of course, we want the longest continuous chain. So this is going to be our parent group. So this is cyclohexane. And we got 2 substituents here, a methyl group, and then this 3-membered ring, which is going to be a cyclopropane. But we're going to change that ANE ending to YL because it's a substituent now. So it's an alkyl group. And again, we're going to give them the lowest number and list them alphabetically. So this becomes 1-cyclopropyl 1-methyl cyclohexane. Okay. Okay, so then you guys, some of you asked about this one. So what's the IUPAC name for this compound? We have 3 carbons in a ring. They're all single bonds. So cyclopropane, cyclo telling us it's in a ring, prop telling us 3, ANE telling us all single bonds. Okay. We have a substituent of 2 carbons. Remember, a 2-carbon alkane is ethane. But since it's a substituent, we're going to replace that ANE ending with YL, so it becomes ethyl. And we don't need to number it because it's only 1 substituent. It would all be equal here on a cycloalkane. So this becomes ethyl cyclopropane. Last thing, you guys, is just make sure that you are not only watching videos, you really need to work the problems. So I have experience discussing this with several students, not from this year, but from all the years I've taught this class and all my classes, is that sections where students tend to just watch videos, they tend to do poorly on. And the sections where they tend to work problems with their tutor and even create their own problems and work those problems, they tend to retain the information better and perform better on exams. So I highly encourage you guys to work problems. Remember, we have an exam starting this Thursday, October 15th. It will open at 12 a.m. So as soon as the clock turns to Thursday, and it will be available until Friday at midnight, well, 11:59 p.m. But remember, once you start it, you must complete it. Okay, you cannot go away and then come back and do it again later. Okay, so once you start it, you have to complete it. All right. Good luck, you guys. Please take care of yourselves. Make sure you're eating well. Make sure you're drinking enough water, getting enough sleep, getting some exercise, taking some time to be just quiet with yourself. Okay. All right. Take care. And again, just let me know if you have any questions or any concerns.